So just basics of matrices first. Okay, a matrix is just a way to arrange some numbers. When we have a matrix, this is an example of what one looks like. We usually name we name the dimensions based on how many rows and how many columns it has. So when I look at this first one, I'll start by saying, well, how many rows does this one have? It has 3 rows. And then columns go vertically. How many columns would this one have? 2 columns. Now, when we write the dimensions, we always write the rows by column. So we would say 3 by 2, rows by columns. The way my brain does this, I literally look at it and I count down kind of like an L. So I'll count down this way and I'll count over this way. And that's how I always do my dimensions. I go 1, 2, 3 by 2, 3 by 2. I just do a capital letter L in my brain. Now, each little number in this matrix, all these little numbers, these are what are called the elements of the matrix. It's called an element, and we can individually find elements using a specific notation. So first thing we're going to do is they're going to put a big letter, and that's usually just the letter that represents the matrix, and it can be any letter. I usually just use A. And then they'll put 2 little numbers as a subscript. The first number is going to be the row number. First number is the row number. The second number is the column number. Okay, so if we need to find element 3, 1, I'm going to use this matrix that we just looked at right here. So that's telling me to look at the third row, row 3, and first column. Okay, so looking at that matrix, if I go down to the third row and look at the first column, what element or what number is in that spot? 7, yeah. So element 3, 1 is 7. For the next 4, we're going to practice naming the dimensions on each of these. And again, how my brain does it is my brain counts down this way, over this way, down this way, over this way, down this way, over this way, down this way, over this way. So the first one, if I'm doing rows by columns, what's the size of this first matrix? 2 by 1. Very good. 1, 2, 1. 2 by 1. What about the second one? 3 by 1. 1, 2, 3, 1. Okay. What about the third one? 3 by 2. Excellent. And the fourth one? 2 by 3. Pretty easy so far? We're saying what's out there. And matrices don't necessarily all have to be teeny tiny. They can get really large too. Obviously, I try and make them paper size. Next up, we're going to look at how to add and subtract matrices. You can only add and subtract matrices if they have the same dimensions. Good job. If they have the same dimensions. If they don't, you can say undefined, or you can say the dimensions don't match or something like that to word it out. So looking at these two, what's the dimensions of this first one? 2 by 2 and another 2 by 2. So since they have the same dimensions, I know I can add them together and it'll create an answer matrix that's also a 2 by 2. Okay, and when you do this, you're basically just combining the numbers that are in the same positions. Okay, so I'm going to take the number that's in row 1, column 1, and I'm going to add it to the number that's in row 1, column 1 on the second matrix. Again, as I said, if you can add, subtract, and multiply, you can do today's work. We'll have 3 plus 1, which is a 2. And then we'll just move our way down the row. 0 plus 4 is 4. Negative 5 plus 2 is negative 3. And negative 1 plus 0 is 1. Pretty good? Okay, the only thing that's different about the second one is instead of adding, we are subtracting. Now, if you're going to make mistakes anywhere on any of this, a lot of times people really struggle with subtracting, especially if they're subtracting negatives. So just be real careful with your calculations. They are the same size, so it is going to create a matrix that's also the same size, another 3 by 3 matrix. And we're just going to carefully go through and subtract the elements that are in the same positions. So starting with 13 minus 4. 4 minus 1, 3. 5 minus negative 4, 9. And then working our way through the next row, 6 minus 9, good. 7 minus negative 3, 10. 11 minus 3, 8. And then our bottom row, 24 minus 15, 9. Negative 3 minus negative 2, 1. Negative 1, yeah. If you ever need to, if you're unsure of your calculations, just grab a little pencil at negative 3 minus negative 2. 2 negatives in a row, remember that turns into a positive. Sometimes it's easier to literally see it like this. That's how we get our right answers. And then 22 minus 17 would create 5. Are you comfortable with that? What about the next one on the bottom left? Undefined. Why can't we add these? Not the same dimensions. Good. Okay. And a lot of times if this shows up on a test or a quiz, I'll ask you to say why. And you would just say not same dimensions or mismatched dimensions or something like that. Right? Not the same dimensions. Okay, along with adding and subtracting, you can also take a matrix and multiply it by a number. We refer to that number as a scalar. It's just a synonym. A scalar can be positive, negative, it can be a decimal, fraction, a whole number, integer. It can, I guess it could technically also be a variable. And it doesn't have to be a specific size. You can multiply a scalar into any size matrix. It's going to create a matrix that is also the same size. So my new matrix will be still a 3 by 2. And we just need to take that negative 2 and we basically distribute it to each number in the matrix. So every element gets multiplied by negative 2. So along my top row, I would have a negative 8 and then a positive 2. In my second row, what am I going to have? A negative 2 and 0. And then along my bottom row, I'll have a negative 4 and a negative 14. And then before we move on, just identifying what element A32 is. So I'm going to use the answer matrix for this. Okay, remember what that means. That means the first number we look at, is that rows or columns? That's row. So row 3, column 2. So in my answer matrix, what is the element that's in the third row, second column? Negative 14. Right. On the back side, we have some that are kind of multiple step. Also some that we're maybe solving for a specific variable in the matrix. Matrix. All right. So look at this one. This one's kind of multiple operations. You can see I have a scalar outside of the first matrix, and then I have added to the second one. If I'm thinking about order of operations, should I add first or multiply first? Always multiply first, right? So I'm going to start by taking that 4, that's the scalar, and multiplying it into that first little matrix. That would create, let's see, that would be negative 8, negative 32, 20, and 0. And then my step 2 will be to add it to the other little 2 by 2 matrix. What size is the answer going to be? Still a little 2 by 2. Okay, again, you're just adding the numbers that are in the same position. So negative 8 plus negative 3 would become negative 11. Negative 32 plus 8. Negative 24. 20 plus 6 is 26. And 0 plus negative 5 is negative 5. Try and not use a calculator when you do these, especially when you do your homework, because on a question like this, on a test or a quiz, you wouldn't have a calculator. So you want to try and build up that skill. We're pretty weak at adding, subtracting, and multiplying negatives. So we want to work on that so we get that skill built up. Looking for element A12. So again, I'm going to use my answer matrix. That's telling me to look in which row? First row, but the second column. So first row, second column, what's that element? Negative 24. All right. Looking at the next one, do y'all see that there's two missing variables in this one? Everybody see that? Two missing variables. Okay, so I'm going to start by just solving for x. So to do this, we have a 2x2 matrix that was added to another 2x2 matrix, and we got this little answer 2x2 matrix. So I'm going to focus in on what specific elements were added to get the numbers in the answers. So this negative 3x was added to this 9 to get what answer? Negative 6. So I'm going to go over to the side and just write a little equation that says that so that I can solve for x. So negative 3x was added to 9. We got an answer of negative 6. What would I do first to solve this? Good job. Negative 6 minus 9 would be negative 15. Dividing both sides by negative 3 tells me that the x was 5. Don't you have? Okay. Now remember, there's one more missing variable, so I'm going to repeat that process, except now I'm going to focus in on what did we add to y? Everybody see where the y is? Okay, so this y was added to what number? 3, because it has to be the one that's in second row, second column. To get what is the answer? 9. The y was added to 3 to get 9. All the numbers are in the same position, second row, second column, second row, second column. This one's a much easier equation to solve. The y was added to 3 and we got 9, which means y was 6. Doing okay so far? We'll go back there. Come, we'll do that later. Okay. Looking at the third one, one's a slightly more complicated matrix equation because we can see there were two little 2x2 matrices that were first added together. Do y'all see the big parentheses that they're in? Everybody see that? They're in these big parentheses because outside those big parentheses is what number? 3. So then they were both multiplied by 3. And then the answer matrix is over here on the right. So there's different ways you can do this. You can actually, if you want to, you can actually add these two matrices together. So you just have to focus on one. Or you can, again, just look at specific little elements one at a time. I'm going to do the same as I did on the last one. I'm really going to focus on just what elements were added and what did we multiply. So if we look at where the 5x is, 5x. So we took that 5x and we added it to the element that's in the same spot on the second matrix, which is what number? 3. And then all of that was in parentheses. And what did we do after that? We multiplied by 3 on the outside. And we got an answer of what? No, the answer matrix is on the right. Oh. Negative 21. And so looking at it, it's always top left, and then we multiply by 3, and we got this top left number. I'm going to write that equation out now so that we can solve it for x. And so we took the 5x that was in the first row, first column. We added it to 3 on the second matrix. And then all of that was in a big parenthesis. And we multiplied that big parenthesis by 3. And we got the answer that's also in first row, first column in the answer matrix. Again, this is just one way to do it. What could I do to solve this equation? Anyone? Yeah, you can start by dividing by 3. Do I need to divide what's in the parentheses by 3? Nope. Just in front and just on the right side. So that'll give me 5x plus 3 equals negative 7. And then what? Subtract 3. Giving me 5x equals negative 10. And then if you divide both sides by 5, what's that x going to be? Negative 2. Okay. You okay, Nixon? All right. Okay. Looking for my second variable. Everybody see where it's at? The negative y. I'm going to switch highlighter colors for this. negative y, it's on the second row, second column, was added to the number that was in the second row, second column on the first matrix. And what else did they do before they got an answer? They multiplied by that 3 on the outside again. And then they got the answer that's in the second row, second column on the answer matrix, which is what number? Negative 24. Good. So I'm going to write out that as an equation. Let's technically this one also. So my solve for y. Okay. So the negative 4 was added to negative y. And then all of that was multiplied by the 3 that was on the outside. And they got an answer of negative 24. What could I do to solve this one? You could divide by 3. Yeah, you could also distribute if you didn't want to divide by 3. It works the same answer. That would leave me with negative 4. Right where it says plus negative, what can I write instead of plus negative? Just minus. Just 1 minus. Equals negative 8. And then what? If I'm solving for y? F4. Giving me negative y equals negative 4. And then if you divide both sides by that negative, what's the y? 4. All right, the last one is a little bit different. Y'all see how the answer looks, or the question looks different? So it's not a lowercase variable, it's actually an uppercase variable. Our answer is actually going to be a matrix on this one, okay? So we're basically trying to isolate this x, which technically that x is going to be a matrix. Okay, if I need to isolate that x, the first thing I want to do is I want to cancel out this entire little 2 by 2 matrix. We're going to cancel that little 2 by 2 matrix by subtracting it off of there. But if I subtract it on the left, where else am I going to subtract it? On the right. Okay. Not too bad. We know how to do that. We know how to subtract. We're going to minus it here. Okay, and then we're going to minus it on the right as well. Okay, so on the left side, it's just going to cancel. It just goes bye-bye. And what do I still have on the left, though? 4x. Still exists. 4x. Okay, on the right side, I'm going to actually subtract my 2 little matrices. So element by element, just like we did on the front. 21 minus 1. 20. Negative 11 minus negative 7. That actually turns into negative 11 plus 7. It's not 18. Negative 11 minus negative 7 turns into a negative 4. Yeah. Negative 25 minus negative 9. Very good. Negative 16. And then negative 33 minus negative 9 would turn into negative 33 plus 9, which is negative 24. Nice. Okay, now to get the x isolated, we're going to kind of use what we did on the front side. You remember on the front how we were able to multiply by a scalar? We can do the same thing here. To cancel that 4 on the left, I'm going to multiply by 1/4. But if I multiply this by 1/4, where else do I have to multiply 1/4? On the other side, which becomes a little scalar that we have to distribute. Well, we're going to cancel. We'll be left with our x variable matrix is, what's 1/4 times 20? 5. And then 1/4 times negative 4? 1/4 of negative 16? And then 1/4 of negative 24? 6. Our answer is a full matrix on this one.